Okay, this lesson today is 13.4 linear equations in slope-intercept form. It's actually going to cover more than that probably. We're going to be looking at lesson 13.2, or parts of 13.2, and 13.2 is called, I don't remember off the top of my head, I want to check, it's called slope of a line. So I'm not spending time on that. I'm just going to point out some key concepts at the end of this lesson because we've already done 13. We've already talked about slope in the earlier chapter, in chapter 5. Then there's 13.2e, and 13.2e is called, I think it's parallel. I do that, well, I'll do this. Parallel and perpendicular. That's the sign for perpendicular lines and slope. Okay, these are all dealing with slope. And we did an enrichment activity on parallel and perpendicular lines, but I just want to bring some items to your attention. And then 13.3, we spent an enormous amount of time on, and that's graphing proportional relationships. So we spent an enormous amount of time on that and determining whether a line is proportional or not, and what k is, and we talked about all that. So because of that, there's little pieces that I want to address, but I'm not going to go through those lessons and spend time on those lessons, and we're going to skip right to linear equations in slope-intercept form. So in this lesson, excuse me, in this lesson, we're going to be talking about the word intercept, and we've already discussed that a little bit in here. The intercept, you have an x-intercept and a y-intercept, and more commonly we do y-intercept form, and that's really the most popular way to write a linear equation. But you do have an x-intercept too. The x-intercept of a line is the x-coordinate of the point where the line crosses the x-axis when y is 0. So anywhere, whenever you have a line, and here is your x-axis, whatever the point is that it crosses that line. So if this point is 6, then your x-intercept is 6. If this point is 10, then your y-intercept is, or x-intercept is 10. And it can also be negative. You can have a negative x-intercept, okay? Then there's also the y-intercept, and that's really what we spent a lot of time talking about. That's your plus b or minus b in slope-intercept form. So the y-coordinate of the point where the line crosses the y-axis when x is 0. So that would be this point right up here. That's your y-intercept. That's your b, your plus b that we talked about earlier in last chapter. So when we're talking about slope-intercept form, we're saying that a linear equation is written in y equals mx plus b, that's slope-intercept form. And the slope of the line is m, and the y-intercept is b. And again, we've talked about that already. This method of representing a linear equation is by far the most common method, and really the one that I personally like to use the most. Okay, so the first example that I want to talk to you about is identifying slopes and y-intercepts, and it's really just breaking apart this equation. And again, we've talked about this in my classroom, so this is nothing new to you. So when you have a y equals a negative 4x minus 2, that means that the negative 4 takes the place of your m. It's your coefficient with x. So that equals your slope. Now, I want to just talk a second about that, because when you have a whole number, there is a 1 underneath it. So that really means negative 4 over 1. So your change in y, is down 4. Negative means down, okay? Your change in x would be over to the right 1, okay? That's what that means. So this means that I'm going to go down 4 for every 1 I go over to the right. So if my slope is positive, if I have a positive slope, that means then that instead of going down 4, I'm going to go up 4, okay? And if I have a negative x, then that means I'm going to go to the left instead of the right, okay? So that's really what it means. The intercept is this -2. That means that that means that your point at which it crosses the y-axis is going to be 0, -2. At that point, it will cross the y-axis. And we talked about that before. So again, this is nothing new. It's something we discussed. It's not anything we put in our notes, though, so I want to make sure you have it in your notes. So if you look at this other example, you have y minus 5 equals 3/2 x. Now, this is not in y-intercept form. So like we did yesterday, you would put this in y-intercept form by just adding 5 to both sides of this equation. And if you add 5 to both sides of this equation, you'll get it in y-intercept form. Y equals 3/2 x plus 5. Then you know that m, your slope, is 3/2, which means 3. You're going to go up 3 for every 2 you go to the right. And that your y-intercept is, your b is 5, which means it crosses the y-axis at 0, 5. Okay, that's what that means. And again, these are all review. We've talked about this before, so none of this is completely new to you. It's just that it was never in your notes, so I want you to put it in your notes. Okay, excuse me. Graphing a linear equation in slope-intercept form. This is what we've been doing, okay? It means that you're going to take and find the slope and the y-intercept. So in this case, you know that your slope right here, right, is -3, and you know that your 3 is your y-intercept, which means that you're going to cross the y-axis at 0, 3. And if your slope is -3, that's -3 over 1. That means it goes down 3 for every 1 it goes over to the right. Okay? Now this is huge, because if you have this, do you really need to do a function table? And for a lot of you, you don't like doing that work. So you don't really need to do a function table, because if you have that point, that intercept point of 0, 3, you know that your next point is going to be down 3 and over 1. So if my intercept is right here, and this is where those slope triangles come in, you're going to go over 1, down 3. And then the next point, over 1, 1, 2, down 3, right there. Okay? So you're creating a slope triangle is really all you're doing. And by doing that, and I still would require you to have 3 separate points to make sure that you're doing it right and that you calculated your slope right. But if you're given a linear equation in y equals mx plus b format, you don't even need to do a function table. You can just count over 1, down 3, over 1, down 3, and create those triangles, those slope triangles. Okay? Okay. And again, you can use this. This is a real-life application where you're using a word problem, a story problem to explain a situation. So the cost in Y dollars of taking a taxi X miles is that. Graph it and then interpret it, okay? To graph it, again, your point that you would start at, because your slope is 2.5, 2.5 means you're going to go over 2, well, 2.5 you have to put in, this is why I don't like it as decimals, and I told you guys many times not to put it in decimals. You have to make that 2.5 as an improper fraction. So 2.5, essentially, you know, okay, 2.5 is 2.5. That means that it's going to be 2 times 2 is 1 plus, or 2 times 2 is 4 plus 1 is 5 over 2. So that means you're going to go up 5 to the right 2. For every 2 you go to the right, you're going to go up 5. So your intercept, your slope intercept here is 2. That means the point that it crosses the y-axis is 0, 2. So that's where you're going to start. You're going to start at 0, 2, and you're going to go to the right, and you're going to go up. And then you can go to the right too, and you're going to go up. And you're going to create those triangles and create those points. Now again, I require 3 points. I know your book here is only doing 2, but I require you to do 3 to confirm your line, okay? All right, so now it's asking you to put this in the context of the problem. So in this case, if you're talking about y equals the dollars that it costs to take a taxi, and the equation is that means that the cost per mile is $2.50, because that's the part that's the per mile. That's your unit rate, right? Your unit rate, so that's going to be your $2.50. And since it's 2, your intercept is 2, there's an initial fee of $2 to take that taxi. That's the +2. And again, we did all of this a lot in the last chapter, so this feeds very nicely into what we just did, and you are just building on that then, okay? Okay, so what I'd like you to do is I would like you to pause your computer. Actually, I think I'm going to move on. I think what we'll do is, I think you probably understand that. I'm not going to spend a lot of time on it. If you have questions about that, you can talk to me later. Let's look at number 5, though, because I do want to talk about number 5, or you can ask me in class. Number 5, I just want to put it in the context of the problem, okay? Y in dollars in taking a different taxi, X miles, is Y equals 2X plus 1.5. What does that mean? That means that it's going to be $2 per mile. I want to make sure you understand how to put it in the context of the problem. And that it's an initial charge of $2.50. A lot of times things like that get put into decimals because of money, but when you're doing slope, it cannot be a decimal. It needs to be in an improper fraction. Okay, so for practice, what I want you to do is I want you to do number 5, and I want you to do number 7. 5 and 7 in your notebook. But I do want to talk to you about a few things before you do that. And these are just a few little tidbits of information that I think that you need to have in your notes. Slope, okay? And this is why, I'm going to be really honest with you, this is why I like the y minus y over x minus x. Because if given a line, or if given an equation, I always struggled personally with determining whether it was positive or negative, and then having to remember all of that, and I didn't want to remember that, and it probably has to do with the fact that I'm a math person and I like to calculate. So I always like this formula, but you need to understand that there are ways to determine whether something is a positive slope or a negative slope, and you're going to have to know how to do that. So a line that essentially goes from the first quadrant to the third quadrant, and it's going up, okay, like this, to the right, it goes up, that's considered a positive slope. That's positive, okay? Now, a negative slope is just the opposite. It's a line that's going from your second quadrant to your fourth quadrant, okay? It doesn't have to go through the origin, but it's heading essentially from second to fourth. This is why I told you yesterday when you were doing your exit slip to extend, or in your graphic or your formative assessment too, to extend that line so that you can determine positive and negative slope. Now, you also have a slope of 0, and you have a slope of 0 when that line is horizontal, okay? When you have a horizontal line, you have a slope of 0. When you have a slope that's a vertical line, we call that undefined. That's an undefined slope when you have a vertical line. Okay, so a slope of 0 is a horizontal line, and an undefined slope is a vertical line. Now I'm going to show you why, because I figured you would want to know why. Okay, this is a slope of a horizontal line. If you take that y minus y over x minus x, and if you take, so your points 5 minus 5 over 6 minus negative 1, and hopefully you all know how to, and remember how to do that, you end up with 0 over 7. Well, you can divide 0 divided by 7, and you get an answer of 0. Okay, so that's why your slope is 0. Now, a vertical line, if you do the same thing, and again, you use this formula, y minus y over x minus x, your point are right here. Okay, so you're going to take 6 minus 2 over 4 minus 4. You end up with an answer of 4 over 0, and you can't do that. Your 0 cannot be your denominator, okay? So because of that, it comes up as an error. So it's considered then to be undefined. You have an undefined slope, okay? Your slope then is undefined. So whenever your zero is on the bottom, it's undefined because we can't divide by 0. Okay. So the other point that I wanted to bring out or talk about is, and we did this on an extension activity, is parallel lines. And I just want you to have this in your notes so that you know it, because it might come up at some point. Lines in the same plane, meaning they're on the same coordinate plane, do not intersect, are considered parallel lines. It's kind of like train tracks. I think you probably learned this in 6th grade. Non-vertical parallel lines have an equal slope. Okay? They'll have a different intercept, but your slope will be the same. So if you calculated your slope is going to be identical. You have here, in this problem, a slope of 1/2. And in this line, you have a slope of 1/2. So the slopes are the same, but your intercepts are different. You're going to cross the axis here at 0, 3. That should be a 0. And here, you're going to cross the axis at 0, -1. Okay? So your intercepts are different, but your slopes are the same. If your intercepts are different, but your slopes are the same, then you have a set of parallel lines. They are parallel. Okay? And I know that's really sloppy. I'm sorry. That says parallel. Now, perpendicular lines. Perpendicular lines and slope. The relationship of perpendicular lines and slope are the lines are in the same plane, meaning they're on the same coordinate plane, and they intersect at a right angle. That's called a perpendicular line. Two non-vertical lines that are perpendicular, meaning non-vertical, meaning not x and y, the product of their slope is -1. Okay? So vertical lines are perpendicular to horizontal lines. So if you look at these two lines here, okay, you have a slope here of -2, and you have a slope here of 1/2. If I multiply those, -2 times 1/2, what do I get? I get -2 over 1 times 1 over 2, which means I end up with a -2 over 2, which is a -1. Whenever your slope is -1, and it does not matter what their intercept is, okay, the intercept does not matter. Whenever the product of your slope is -1, you have perpendicular lines, okay? Okay. Let's see, what else did I want to talk about? Anything else? No, I think that's probably it. Yeah, I think that's it. Okay, so you need to do those two problems on page 594. I want you to do numbers 5 and number 7 for tomorrow, okay?